How does crack initiation start fatigue cracks? Imagine a tiny crack forming in a metal part after many cycles of stress. This small flaw is the beginning of something much bigger, and understanding how it starts is key to preventing failures. When a component is repeatedly loaded, certain spots become stress hotspots. These are usually surface defects, sharp corners, or areas where the material isn't uniform. These spots experience higher stress than the rest of the part, making them prime locations for cracks to begin. Repeated loading causes microscopic changes in the material. Tiny dislocations, which are defects in the crystal structure of metals, start to move and pile up in specific areas. This movement creates narrow zones called persistent slip bands. These bands are zones of intense plastic deformation, meaning the material is permanently changing shape at a microscopic level. Over time, these zones cause tiny surface bumps and dips, known as surface intrusions and extrusions. These features act as starting points for microcracks, tiny cracks that form within or near the slip bands. The process of crack initiation can take a long time, especially in high-cycle fatigue, where the loads are low but the number of cycles is very high. Each cycle causes small amounts of damage, slowly growing these tiny cracks. Once a microcrack forms, it can grow little by little with each load cycle. This growth is called stable crack growth, and it continues until the crack reaches a size where it can suddenly cause failure. Several factors influence how easily cracks start. The strength of the material plays a role. Stronger materials resist plastic deformation longer. The surface condition matters too. Rough or damaged surfaces have more stress concentration points. The level of cyclic stress and how the load is applied also affect crack initiation. Microstructure, including grain size and alloy composition, influences how dislocations move and gather. To prevent crack initiation, engineers use techniques like polishing surfaces to remove roughness, introducing compressive stresses through shot peening, and designing parts with smooth, rounded edges instead of sharp corners. Regular inspections focus on these vulnerable spots to catch tiny cracks early. By understanding how cracks start, we can design better components, choose the right materials, and apply protective treatments to extend their life and avoid sudden failures. Recognizing the microscopic beginnings of fatigue cracks helps us prevent big problems before they happen, keeping machinery safer and more reliable.